for this week. Yeah, for this week, we're gonna be available from I'm gonna be in the classroom from Wednesday until Friday. And then I have the breadboard. So if you want to make that purchase, come and see me. And then it's $27 for the breadboard. And then after that, I will teach you how to do the breadboarding and how to do your first dlab. Okay. So that is in the classroom. Like I said, it's going to be Wednesday, Thursday, and Friday. It's from 3 p.m. until 7 p.m. So if you are available, please drop by the classroom, and so I can teach you how to do your breadboard. Okay, and then the other things that I want to mention is that the D review on the website. So don't work on that one yet. We're still trying to fix that problem. And that's pretty much it. Just those like I said, the breadboard is will be available in the classroom. So and I will able to lend you the rest of the parts, the IC and the tools that you're going to need to build your breadboard. Okay, so come and see me Monday to Wednesday. So Wednesday, Thursday, Friday, from 3 until 7 p.m. Okay. Any other question? Anyone?
Did you buy extra boards or only for who requested?
I purchased 20 boards, so there's should be sufficient enough for people here because some of the students is already from previous semester that already have their boards, so I don't think that there won't be a problem. Okay.
Is there a specific function that our breadboard is supposed to like do?
What do you mean? How are we going to test your breadboard?
Like, is there like specific function that we're making the breadboard for like a specific circuit or something like that, or we're just making?
Yeah, you're gonna be doing the circuit like you said. If you look at the first assignment on Tech 2 on the website, it's a dlab 01. That's what you're gonna learn how to build. You look at that schematic and you're gonna build that. You're gonna build that circuit, and then once you completed building that circuit, you're going to have to develop a software program to test that circuit. Okay. So you're going to be, so this is, so you're going to be seeing this, this is the dlab 1. So dlab 1, you're going to see is this a schematic, and this is what you're going to learn how to build. Okay, you're going to look at this schematic and learn how to build it, and that's what you're going to be doing a lot when you're working outside as a technician. If you're going to work with an engineer, that you're going to develop a lot of prototype board, you're going to look at this schematic. So similar schematic like this, it would be more complicated, but it will be sufficient. Yeah, so you're going to be learning just the basic here and then continue on until you get to the point that you're going to be building a more sophisticated circuit later on in semester. Okay. Does that answer your question, Hugh?
Wait, hold on. dlab 01, that is from the spring 22 Tech 2 assignments?
Yeah, that's his spring 20, yes, Tech 2, right here. Okay.
dlab 01 Logic Gate.
Yes.
Is that the same one?
That's the one, yes.
Okay, cool. All right, yep, gotcha.
So you're going to be you're going to see this schematic, and then you're going to be using all the wire jumper that you can. So you're going to get the IC, the 7400, 7408, 7432, 7486. And you're going to run a jumper between U1 pin 3 connect to U4 pin 1, and so on and so on. So you're going to be connecting all these circuit, and then we're going to run it against the control box using port C as an output and your port A as your input information. And your port information, your input information is based on this truth table right here. Okay, or your timing here. Okay, so. Okay.
Thanks, Sam.
You're welcome. Okay, any other question? Anyone? Okay, thank you, Mr. Pham. Back to you.
Thank you, Sam.
You're welcome.
Hello, everyone. Okay, I get something to let you guys know. From next week, in class, lab will be Tuesday, Wednesday, and Thursday. Textual lecture will be on Friday. Okay, so make sure you know that. I wanted Friday so I can stay at home and talk to me. Okay, now today, first thing I will be talking about the dlab, and also telling you who will be able to get a certificate in this semester. Okay, let me share the screen. Okay, any student okay, start the program. From summer. Just a minute. Is it last summer 2021, right?
Yes, 2021.
Okay, 2021. Now, before. Unit complete. You. You get the certificate. Okay. If you start from last semester for Tech 1, this for Tech 2, then you still meet AC on the summer. So that takes a little longer, around 2 months, to complete the summer 2022. Okay, anyone get any question? Just bring it up.
Is there any specific modules that we have to complete? Because there's like a lot of modules for the lab volts, right? Is there any like really specific ones that we really need to?
Okay, if you
finish?
see on the board, when you go into the class, on the board, they already put up there what Tech 1 level need to be done in the Tech 1. I believe so. They already deleted what module, like, you know, these transistor amplifier, okay, or op amp, or JFET, or, you know, that field up there, you can look up there. We not expect 100%, 70% or more. That'd be okay.
Okay, thank you.
You're welcome. Okay. Now we're talking about Tech 2. On Tech 2, the lecture is not much, but the important thing and more working will be in the lab. Okay. And I'm telling you the process. How can you do the lab for Tech 2? Okay, on Tech 2, left one, you get choose circuit board. That's a very simple one. That's a digital one or digital 2. I believe so. Okay. Maybe 13 or a little more. And now we're talking about the process to do the dlab.
Mr. Fan, what do you mean by 13 or more lab? You mean
Again,
13 board or 13 attendance?
13 a lab. I'm not talking about attendance.
The board then.
Right.
13, yeah, dlab, yeah, dlab that you're going to have. It's going to be assigned on the website.
Okay.
So not in person?
You can come into in person. Like I said, the lab will be open from starting, like Mr. Pham said, next week. It's going to be only for Wednesday, Thursday, let's see, Tuesday, Wednesday, and Thursday starting next week. And
No, I'm
Friday,
talking
you're going to have lecture on classroom. So yeah, you can definitely you can go into a classroom and build your board and testing it, or you can build at home and then you can take it to classroom and running tests on it.
Okay, got it. Thank you.
Yeah, because we have the control box only in the classroom.
Okay, now you can see here, and you can see what you going on and what you need to do. Okay, the process for the dlab. First thing, you need to complete Excel. File, okay? And second thing, develop your test program. To test the circuit. Okay. Number 3, compile. No error. Okay. Upload file dot cpp or dot txt. Okay. Number 4. Okay. Mr. Sam. Will run your program. With the hardware. Okay. And we'll let you know. Good. I say part. Fail. So basically, he will be running your program with the hardware we already have it. If it part or if it fail, he will be let you know. Okay. If fail, redo your program. And upload again. Okay. That just make sure your software is good. The thing is when you build your circuitry and you test with your software, then you don't know your software good or the board you build is good. If it fail, you get to a no. Okay, one is the hardware. That means maybe wrong for wiring or whatever. Maybe your software is not good. So that's why we cannot solving with you unknown. So that's why I said you have to upload your software and Sam say, okay, your part, your software. So when you build a circuit, you run it, it fail. That means your circuitry build is not correct. Okay. And number 6, build a circuitry. Okay. And run in cloud. I think you have to run in the cloud. And the lab instructor will verify. Okay, so the lab instructor, after you build and you run in a cloud path, and now you need to let the lab instructor, they come in and try to see, make sure it's working. Then they have to report to me, okay, to see who done, who not done. So that's why when we try to give in a certificate, I'm looking into that, okay? If you get, 13 lab must be done, and you get only a half of that, not really done for the dlab, then you have to stay until every lab must be done. Okay. And we can let you, we can give it to you all of the things you need in order you can build. That means you can take out the park, the tune, everything you can build at home. Okay, you don't have to be in the cloud. Only thing is when you try to run the test for test your circuitry, then you have to run in the cloud. The thing is you don't have a system board connect into your breadboard. Okay, so up to this point, you get any question, anything? We try to see we can help you guys to get the job done as much as we can.
Mr. Pham,
Yeah.
on that 13D lab, okay, I believe with all the classes that we've done so far, on the Tech 2,
Mhm.
the most you gave us was 10, I believe.
Yeah.
So
Now
we'll-
the thing is, some student I know, that means you start before 19, right?
Mhm.
Then that is not the following from at the beginning. Okay. Depending on what you want to do until you can get into the lab, and that really you're not done yet.
Okay.
Okay.
I'm just saying that we've done up to 10 lab from previous semester.
Maybe I think you already done up to the memory.
Test memory, yeah. The 2114 RAM.
Yeah, that's a RAM memory.
Right.
Okay.
So if we want to go further, and if we run out of time at the semester, or can we get the notes on dlab 11, 12, and 13 that we can read and then maybe try?
Yeah, that's what I'm working on.
Okay, I appreciate it. Thank you.
The thing is, we don't want to waste your time. I hope very soon company will be stuck, hiding the student for technician. Only thing, make sure you have to understand what you're doing, okay? Have to understand. That's the key point. The dlab will be helping you what? Helping you how to troubleshoot it. Both hardware and the software. Whatever I already know, I already did it. That's what I try to give back to the guy, okay? The thing is, sometimes you run the test and the test fail. We not try to check the wire. No, never. You build one time. When it failed, then you have to know what failed, then what to do in order to find out what's wrong, to fix the problem. That cannot be happen when you do your left volt. That will be helping you here how to isolate the problem, okay? That is normally I have to do all the time. Something going wrong, what can we do?
I have a question. So
Yeah.
I have a question. So the lab volts, when you say 2 boards,
Yeah.
what does that mean?
You get
Lab
two
volts
board,
is the modules, right?
you get two board on the digital to do it. I think that will be digital one. Is it the right, Sam?
Yes, you have digital fundamental 1 and digital fundamental 2.
Oh, okay. Okay, got that. And then the D labs is what we're going to be doing with the breadboards.
Yes, sir.
Right, exactly.
Okay, got it.
Okay.
Okay, if it now, no question. So now I will be going to the dlab at the beginning to the end. What you need to do and try how to do it. Okay. So I believe the fourth one, if you don't know how to do it, just let me know. We'll be trying to explain to you. Okay. dlab Excel here. dlab number 1. Okay. So the first thing you can get that dlab in the Excel. Okay. And on this circuitry here, I already said you need to run PSPI. Now, PSPI is a simulation program. Okay. For the digital. Then you get the input. You need to let them know what your input. and they will be giving you the output. That is the purpose of the simulation. Okay. So now I'm talking about first thing. You get to do your simulation. Anyone get a problem how to do a simulation or don't know how to do it? Bring it up. Otherwise, we can skip it. Okay. To make the time will be less. Now, this is the truth table. The truth table, you get a pin 1, pin 2, pin 3, pin 4 on port A. And now, when you run the simulation, you collect the output for test number 1, number 2, up to 16, and will be filled in here. Okay. If you fill in that data output here, they say part. Okay, so that means your simulation working. Now, on the simulation, you must be enter the data for pin 1, pin 2, pin 3, pin 4. Okay. PSPI cannot understand 0101. No. However, they understand the waveform. You see that PA pin 01. They get 0 at the beginning, go 1, then they go 0, keep going. H1 will be 1 microsecond. Okay, they're telling you they low 1 microsecond, they high for 1 microsecond, and they keep going. Okay, and PA pin 2, they will be low for 2 microsecond, high for 2, and keep going. PA3, 1, 2, 3, 4, they low for 4 microsecond, high for 4, and keep going. And the last one, pin 4 will be 8, okay, microsecond. You see that 1, 2, 3, 4, 5, 6, 7, 8, and they go high. How come we know that? You can see right here. 1 will be 1 microsecond. Okay, so 1, 2, 3, 4, 5, 6, number 8 here. You see that? 8 microsecond for low, 8 microsecond for high. Okay, and on this one, they can get 4 microsecond low, then another 4 for high. H1 will be weighted 1 microsecond. So this one you need to tell the PSPI is your input, okay? So they will be telling you what your output. Okay, so now on this one here, you know how to get the part, right? 7070 8 86 86, and you get U1, U2, U3, U4, U4, U4A. You understand in one IC for 7486, you get 4 IC inside, 4 gate inside one IC. The first one, they say A, then they already telling you pin 1, 2, 3. If you select a second one, that means B, automatically they change the pin number here. Okay. So that is how you can draw the schematic. So up to this point, any question? And you have to understand it later on. We don't have a much dlab using the PSPI simulation. Why? The reason is the park we're using to make the dlab, they don't have in the library. Okay? If they don't have it in library, nowhere you can run simulation. That will be required understanding. Okay? Understanding in order to develop the program to test it. In the company, we do the same thing. However, PSPI in the company cost much money, 10,000. So they get everything they need. But what we get is student version free. So we'll be limit on the IC in the library. Okay. Few dlab will be using PSPI. Most of the lab will have to understand it. Okay. So up to this point, you get any question? If it's not, now I can show you in the PSPI. Let's say dlab 1. Okay, this is in PSPI. Okay, before I go in a little detail here, I just try to see we can analyze it, set up. Okay, the setup will be a transient. You understand the transient using for oscilloscope. Okay, and on the foot, okay, on the foot here, bring the step, you don't care. However, only you care right here. Final time. What final time you think we should set it up? I just want to make sure you understand. Not try to say in the past, they do that way and you just follow it.
Use 2 to the n.
Final time. What do you think you put in the final time? That's the only thing you have to get in here. How do we know? I said 20 microseconds.
Use 2 to the n. Use 2 to the n.
Okay. 2 to the n. What is the n?
You can see on the Excel file and estimate how much time do you need for the simulation.
I just asking you. How come I enter 20? If you understand this one, you get another one, you're able to know how to do.
Could you please show the Excel file, Mr. Pham?
What?
The Excel sheet, the Excel file.
Excel. Okay, just a minute. Okay, Excel here.
Yeah, could you move a little bit lower? Okay, there. So looks like based on the first on the PA01, you can get an estimation that 2, 4, 6, 8, 10, 12, 13, a little bit more than 30 microseconds should be enough to run the simulation.
Now, anything you still can run the simulation.
Yeah, but your question was, how can I figure out the total time? I'm trying to replay to answer your question. You have to pay
Yeah,
attention.
but
For
the
this.
thing is,
It's
how
2
come
to
you
the
come
4.
up with 20?
It's 2 to the 4. Because 2 to the 4 is 8 and you have 16 tests. So,
Okay, now,
so you don't want to put 16, you want to put a little bit more. So that's why you added 4 more.
okay, you're right. Okay, now I'm telling you, you're going from the top
Right,
to the bottom here,
right,
16 microseconds, correct?
correct.
Okay, so the thing is you don't want to put exactly 60. You given a little more, okay? So they can display and you can collect data up to 60,
Mhm.
okay? That is the reason why I put 20.
But Mr. Pham, you're saying you use, as I was saying, you use the 2 to the n formula, and then you n is equal to 4. So then that gives you 16. And then you, like you said, you want a few extras. So that's why you put in 20.
Exactly.
Or show what one microsecond does, and then apply 5 microseconds, and then apply 20 seconds, so that are 20 microseconds, so that you can see what the signal is actually displaying. So it's understood when you apply the clock, and then you try to align all other data, the final time will reflect why you're changing from 1 microsecond to 20 microsecond steps, or excuse me, not steps, but the reason why you want to have that 1 microsecond versus 20 microseconds. So you display that you display the signals that you want there on your Excel sheet to show how the final time works.
Yeah, final time depending on how many tests.
And,
Have
and
to
your-
collect the data for 16 output.
so your PA1 is 1, PA2 is 2, PA3 is 4, and PA4 is 8. So 1, 2, 4, 8. And then you have 8 zeros and 8 ones, which is 16 tests.
Okay, now you can see I can run. Analysis, simulate. Okay, when you see the black here, that's a display like oscilloscope. Then you okay. Otherwise, you can get a problem. Okay, now click here. So you try to remove that. You don't need that. Okay, you want input. 1,
But I'm not going
2,
to help people
3,
because
4.
what they do is they don't work on stuff. They just
Output will be 1
You
and
need
2.
to work on it for an hour or whatever, so you can toil in it and think and try to do it yourself. And then after about an hour,
Joe, can you mute your mic?
Okay,
Okay, now when you run, if the display green, that means look like you okay. If you get a different color, some wrong. Okay, sometimes you get the red or blue or whatever. That's something must be wrong. Now you want to collect the data. This is the test number 1 here. And you can look output, you can get P1, pin 1, logic 1, logic 0. You go to this is 2, okay? And you can go collect the data out. 3, 4, 5, 6, 7, 8, 9. And you keep going until you go up to 16. Okay, that is how to collect data. You given the input PA1 up to PA4, and the simulation given you the output for PC1 and PC2. Okay, so any question on how to collect the data? Okay, if it's not, the last one on the simulation here is this one. How do we tell the pitch pi? We get the signal. Like I already showed you. This signal here. Okay, how do we tell it? That's what we need to using. Include, okay? If you double on include here, and you need to enter file name, okay? And you can type in C, okay? ETT, dlab01 dot STL, okay? Then now you can go to that to edit your timing. Okay. Okay, now you see. This is your file .stl. Okay, first thing. See a few things here you have to know. IIwEEK1 for the first input, IIwEEK2 for second one, and 3 and 4. Okay. So this line, you can make sure you get IIwEEK1, and the red line cannot be changed. Okay, that means the rest of that one cannot be changed. The second line, they have to type in the pin number. Whatever in your pitch pi, they must be matching here, PA-01, okay? Otherwise, you get an error. Second line, just keep it same way. Don't try to change anything. Now, the next line, 0 means 0 second. At the beginning, what logic? Okay, if you're looking into the Excel, you can see at the beginning right here, logic 0. Okay. At the beginning, 0. How long they will be go to 1? That will be 1 microsecond. Now, you can see the signal. They just repeat over. So that's why they get a formula. They say repeat forever. What you want to repeat? You want to repeat one yield for 0, one yield for 1, and you end for repeat. That's just a formula, not by myself. That's a from PSpice. If you want to do it, you have to follow. And when you go to the second one, IIwEEK06, and the pin, same thing, PA02. Okay? So at the beginning, they start 0. However, how long they go to 1, that takes 2 microseconds. And you can do the same thing, repeat forever. Okay? And you go to IIwEEK03. Okay? And the pin here changing, PA.03. Okay? At the beginning, 0, take them 4 microseconds, they go 1. And you can repeat it. The last one, IIwEEK04, PA04. At the beginning, 0 second, they 0. 8 microseconds, they go to 1. Okay? On this one, you get enough. Okay? 1610. So that's why you don't have to do repeat forever. If you want, that'd be fine, no big deal. However, the timing is not mean they repeat. The thing is, if they get a different duration, sometimes you get 1 millisecond, 1 microsecond, the other one they get 3 microseconds or 5 microseconds. So that's a difference. Repeat forever, only using when they try to repeat the same signal at the same time. Okay? So after you're done, one very important thing, when you say foul, you must say, but never say S. If you say S, they're going out to this project and you get a problem. This is a home project. They go together. So make sure after you create your file, you typing in, okay? And only thing you need to put a say, not say it. So normally you done 1. Later on, you get another lab. They get the timing. You can copy that one to the new one and change whatever we need to change. We're not trying to sit down and keep typing everything. Okay? So on this include file, you get anything or anything you not understand.
So the text file is created.
Now this
by
is
the,
not a text file. The word, they get a .stm, not .txt. But you can use the text file to copy into that project. Okay. However,
Mhm. Yep.
however, you can see that in here, they have to be .stm, not txt. This software don't understand txt.
So the .stm that is created from PSpice.
PSpice, right?
Mm-hmm. So you don't have to write it out, or
Now
you
you
just
have to
make.
write at the beginning.
Okay.
When you try to click on include here. Now, this one. Okay, you can say include. When you click on include here. Enter file name. You see that? dlab01 dot STM. That means the STM will be coming from here. Okay, so that is a simulation. The next lab, dlab2, you get a timing, but not basically sometimes repeat forever, sometimes it's not. You must be understand so you can do the other one. I don't want to say. Okay, now, after you get this done, okay, part, your next job will be go port A, we see here. Now, I understand that one. On the system board, okay, on the system test, they get port A, port B, port C, and port D, okay, for port. However, on this lab, I using input port A, and output will be port C, okay. What you need to do, on port A, or B, or C, or D, all the time, they get 8 pin number. Pin 1, 2, 3, up to pin 8. Okay. However, on this one, we're using only pin 1, 2, 3, 4. So what you need to do is go into your truth table. Okay. This is pin 1, 2, 3, 4. Copy this guy. Control C. Okay. And go to port ABC. Okay, paste them out. Okay. You don't have to type it. Now, this is the data you need using the height decimal. So they start with a 0, 8. Okay. On the time. The one we're not using, basically they're supposed to be 0, 0, 0, 0. However, we know that 0. Now you must be change this number here into height decimal. 0, 8, 0, 0. And the next will be 0, 8, 0, 1. And 2, 3, 4, 5, 6. Okay. Up to A, B, C, D, E, F. If you see they say part, that means you okay. If it fails, that means something must be wrong here. Okay. That's how do we complete data for port A. Any question? Okay, if it's not, now go to port C. Port C here. Okay, they get 8 pin, same thing, PC1 to PC8. However, you're using only 1 and 2. Okay, so your job will be go back to table, copy 1 and 2, Control C, go to port A, B, C here, paste them out. Oh, sorry. Okay, we copy, we paste them out here. Okay, so I make a copy again. Okay, paste them out here. Okay, and now height data. You just turn that into the height. We're not using the 0. So that's why it did will be 0, H01. 0, H01, 0, H01, 0, H00, and keep going. Okay, up to this point, you need to fill in port C and get the height data and equation. Okay, if it's not, before I talking about math data, okay, I talking about P-corp. P-corp that telling you if the test fail, what caused the problem. You get U1, U2, U3, U4. At this time, we not deal with the P-corp. Then that's why we including 1, 2, 3, 4. However, in the future, sometimes you need to tell exactly on the test number 1 it failed, caused by what U number, U1 or U2 or U3 or U4, okay? That means you really understand what you're doing. But this one, we go now 1, 2, 3, 4. Okay. And the last one, math data. What that means? You understand it when you try to reading data from port C. They're not reading only 1 and 2. They're reading all of the bit here. That means reading 8 pin. However, this pin here, you're not using. Then you have to let the computer know, I'm not using from 3 to number 8. So ignore anything you get. So that's why you need the math data. I said, I want only pin 1, pin 2. So the math data, you want it, you put a 1. And this one, you don't want it, they will be 0. Okay? They will be 0 here, 0 here. That only thing you tell the compiler. When you get data from pin number 1 and pin number 8, data from pin 3 to number 8, and with 0. Okay? Whatever they get, they end with 0, they will be 0. That means you ignore. Only thing is the one you're using. You have to end with 1. So that have to be 1, and that have to be 1. So that's why the math data you want it 0.03. If you get a wrong math data, the test will be failed. The thing that the pin you're not using it, they still take care of that pin. It's wrong. Okay, I can ask you a question here. If I want to using pin 8 here, okay, and pin 3 here, what the math? Pin 8 and pin number 3. What do you think the math data?
Zero X 0B.
What the math data? If I using pin number 8 and pin number 3.
Zero X 0B.
Cannot be 0x 0b. You have to follow the formula. 0x, then whatever number. What you take?
Is 0x 8 4.
Good. 0x. Right? Oh, they not allow me to write out here. I just write out here. Okay. 0x 8 4. If I using this pin 8 and pin number 3, then the math data will be 0x 8 4. Make sure you understand, okay? If you not, make it clear. This is very important. If you get a math data wrong, everything will be wrong.
What made it a 4?
0 1, you can see here. 0 1 0 0. Right? You get 4 bits here. Another 4 bit upper here. So 1 0 0 0, that means number 8. 0 1 0 0, that means number 4. You just try on. It's still confusing you.
Mr. Fan, 0x01 indicates 8 bits, correct?
0x 0 1.
In hex data, you're working with 8 bits, correct?
I'm talking about that one, 8 bit.
Right. That's
Here,
what
you can say pin 1 up to
Right,
pin number 8.
right. That's what I'm saying is 0x01 indicates you're working with 8 bits, but 1 indicates
What?
PC01 because of the value of 01 is 1.
That one right here.
Right. So the value of 02 is 2. The value of 03 is 4, and the value of 04 is 8. That's
Depend.
why 4 is 101.
Yeah, 400. That's number 4.
Yes, basically what I'm saying is PC04 is actually a value of 8, and PC03 is a value of 4, and PC02 is a value of 2, and PC01 is a value of 1. But you're only adding the value of that specific location only when you have a high or a 1. That's why it's 4. So you have to understand that 4 is 8, 3 is 4, 2 is 2, and 1 is 1. When you look at the chart, there's a place value for each bit.
Just 1 minute. I want to make sure that will be clear for everyone. Otherwise, okay, now, if I want this pin, let's see. Okay, I want pin 7. Okay, then I put 1. I want using that pin also. I put 1 for map using that one. That means I using 3 pieces. What the map data? Zero, I what?
8.
8. Then what?
6, 8. 0, 6, 4, 2, 6, 8.
Now, try to see. That one we're not using, so we want 0.
Mm.
Not using 0. Not using 0. So what data you think?
6, 8.
Take it, perfect. 0, 8,
6, 8.
6, 8. Okay, the thing is, if you not follow it or understand, just bring it up. We can try to help you. Own up any test program must be using the maps data. The thing is, the output sometimes they get 8 pieces, but we're not using 8. We're just using 1, 2, 3, 4, 5, or whatever. And you must be get the map data correct. Okay, I can give another one here. If I get a 1 here, I get a 1 here. Okay, and I get a 1 here. I get a 1 here. What the math data? We're not using, I put 0. Okay. So what 0 I?
24. It will be 24.
You know, you get a table showing you the relation between decimal, binary, hexadecimal. So you can look into that table.
24 will be F will be 15. 15, F, 15, F9. F9.
No, it's not F.
Yeah,
CC.
15 is F.
C.
F
Looking
9.
back into the table.
F.
1100.
F will be 15. 15 and 9 will be 20.
0xcc.
Perfect.
Huh? Oh, CC. Oh, yeah. Okay.
Just look into the table. Okay. So, any question on port A and port C? Okay, if no more question, the quiz here easy. I'm not trying to explain anything. Okay, now I'm talking about test program. That only thing is, after you start your test program, compile it, ready, no error, copy, put in here, paste them out here. The CPP file or the text file will be okay. And you can see, you get everything part, upload, so Sam will be do his job, okay? So, any question on the Excel and also on the PSPI? The last one, I will be going with the program. And that's only one time, okay? We're not trying to return anything we already done today. This is a technician job. You have to using your brain to working on. I can give you the example here. If you get a pin 1, logic 1, pin 2, logic 1, what pin 3 is supposed to be?
Zero.
0. The thing you did get will be a NAND, right? NAND gate. Okay. So if you get a 2 input in logic 1, output will be 0. Okay. My question is, when you measure the output here, they given you 1 volt. That must be some wrong. In a logic, you get only 1 and 0. 0 means the voltage have to be less than 0.4 volt. But they measure 1 volt, you know something wrong. What can you do? When you measure the U1A, pin 3, supposed to be 0, but you get a 1 volt, it's not 0. You know wrong. Telling me what you want to do.
Measure voltage on A1, PA01.
Okay, you get the meter, DMM. Measure the voltage, DC. Connect meter to U1A, pin 1. Okay, if you get a 4 volt, that will be good, right?
Yes.
Okay, then what next you do?
Test port 2.
U1 pin number 2. what you get, if you get a 3 volt, then what next you want?
Change you want.
Now, you measure logic 1 at pin 1, measure logic 1 at pin 2, and output, they have to be 0. Okay, if they not, then only thing you can say, can remove, replay, you want. Okay, that's a troubleshooting. In order to get the right input, if you not get the right output, that means this part is not working. That's for a simple one. Apply for troubleshooting. Okay. Normally at work you do the same thing. If you measure pin 3 wrong, then you must be check the input to make sure they get the right input. If you get a right input at the input here, then you just give it to a assembler. You want to change that E1. Remember, they get E1. They not care about E1A. That's just like E1. Okay? Inside that IC, they get 4 gate, but they cannot change the gate inside. They have to change the whole thing. So that's why sometimes you're working, you can hit into the problem. For some assembler people, they've been working for a long time. When you keep giving to them to change the IC, you change E1, they not fix your problem. You change E2, you not fix the problem. And that's why sometimes your supervisor will be asking you, okay, why you want to change E1? That's why you have to prove, okay? You can say, I measure the output here, supposed to be logic 0, but it's not. I take the input, pin 1, pin 2, I get the right input, so that's why I change it. Okay, so now, last thing, quickly, go to the program. We don't want to say anything. Okay, the program, the process, how to get into the C++. I don't want to repeat again. Okay, I just try to go. Okay, into the program here. Let's see. Okay, that's wrong. Okay, so basically you understand we already explained to you, okay? Everything here. Same thing. Only thing I'm talking about the test. Test number 1, title. Test title. You know how come you get the test title? let's see. Excel here. We get the step number 1 here. Now you can see go to port ABC. You see that tab title. Okay. Tab title, same thing. Tab number 1 here. That's why I get tab number 1. Tab title, tab 01. Now, expect data that they say from port C. Okay. So you go to port C. Expect data right here, 01. Okay. This is the map data. This is the peacock. So you go into here. Okay, expect data 01, map data 03, peacock 1, 2, 3, 4. That's everything from port C. Okay, now the next, that means you apply the input. Okay, you can say write to port A. If you go into the port A here, the first test number you write data 0x0. Second test data 01. Okay, so that's why you say write to port A. This is the format you must be follow exactly, except the data different. Okay. After that, this day you don't have to do anything. Okay. If no go, that failed that part, that's my software. So you just leave it there. Okay. That's done for test number 1. However, remember, first thing you need to apply input data. Sometimes you have to write to port A, then you have to write to port B, or you have to write to port C, depending on how many input for test 1 they will be applied. Okay. Then this will be following or not the input already applied. So now if you go to test number 2, same thing. You can get test number, test title, expect data, and you can write to port A. You can see in here, test number 2, you don't have a map data and the peacock in the test number 2. Why? Why you don't have to type in on test number 2 for map data and the peacock? If you do, that's okay. It's not hurt anything. But I have to make sure you understand on the software. Do a right thing, right way. Why we don't have to do it in here again?
It carries over.
My question is, normally you can see, you can get test title, expect data, map data, peacock, normally for every test. However, in this case, my question is, how come on tab number 2, I don't have to typing on the map data and the peacock here?
Is it because it's the same?
Okay, exactly. The thing is, if you're looking into your Excel, okay, then you can see you can get only one map data will be applied for the red of the tab. And also you get a peacock, same thing. They will be applied for the red of the tab. Okay, on the basic software, if you're not changing map data, then you don't have to repeat it. You don't have, if you're not changing the peacock, then you don't have to try to repeat it again, except they change it, okay? So basically, if you know how to coding, that takes a very short to get it done. Copy tab number 2, paste it out, do for tab 3, okay? Keep copying, paste them out, changing depending on data input A, B, C in the Excel, okay? Same thing, you see that? That means you can add in your tab here, but not after this line. This is my program. You take care when you run the test, they telling you pass or fail. Okay, so that is how coding. You just create your new project, then you copy the one I already given you on the website, paste them out. Okay, you're not supposed to be sit there and typing everything. No. Only changing any data we need. That is the test program. For any test program in company, same thing. It's not like in commercial. The program will be require more thing. Okay. Okay, any question up to this point? So I believe for this week, some student can get this lab done. And also, I will be notified to you guys. Okay, you're not done yet. You need to working harder if you want to finish the program. Okay, any question, anything? If it's not, make sure you guys understand it from next week. Your in-class lab will be Tuesday, Wednesday, Thursday. And your lecture on the digital will be on Friday. Okay? Tech one will be on Monday. And make sure you download the handout number 3. They're talking about a very important thing in the flip flop. Okay? Try to read before we get a meeting. We hope you can easy to understand what's going on. So, do you get any question to me yet? Anything? Okay, I stop there on this thing.
Hey, Mr. Pham, that 1D review, you said not to do that one, right?
Don't do N number 4.
D review number 4?
Right.
Okay, thank you.
I will change it tonight or tomorrow. I'm working on that. That means I want to try to do exactly how to design the circuitry. Okay. That means after you design the circuitry, you get the input, you get the output, and now you have to put it in your K-map in order to get a minimum number of gate before you want to build. But that's a simple one. I just want you to doing the process. Okay. To know how we design the circuitry. That means you have to get an input and an output, what condition? The output to be 1 or output to be 0. So on. Okay.
So it should
so
be
any-
fixed around Wednesday or Thursday, right?
Can you say again?
It should be, that one should be fixed around Wednesday or Thursday.
Wednesday.
Or Thursday, that one D lab should, I mean, that one D review.
Yeah, tomorrow.
Okay, tomorrow.
The thing is, I'm working on that, and I know different problem, different way to do it. Before we not try to do it, but now I really want for whoever understand, try to say, can you do it when engineering can do it? Okay?
All right, thank you.
Yeah, so good night, everyone.
Good night,
Okay.
Mr. Pham.
Good night.
Good night.
Mr.
Good
Pham.
night.
Good night.
Nice.